it's another presentation. It's coupled, but before presentation. But another problem is treated in this presentation is Žeželj Bridge and critical load due building long arch. It is in memory for Branko Žeželj, Boško Petrović, Dimitrije Ćertić, Ilija Stojadinović, and Stanko Šam. This paper showed the influence of critical load along spine arch of Žeželj Bridge in Novi Sad. The construction of scaffolding, large span concrete arches before the Žeželj Bridge in Novi Sad was very expensive. That is why Žeželj envisioned the construction RC arches in 3 longitudinal parts. But due to rheological properties of concrete, primarily due to influence of creep and the lesser extent shrinkage, the arches were temporarily interrupted at the top. The dilatation was left and top of the arches. Since the arches were also longitudinal segment in stage, the scaffolding was designed for only about 4% of load, which significantly reduce the cost of the scaffolding a large arch. Namely, originally the arch was smaller, but due to the condition of the Danube Commission regarding the free waterway, the span of large arch increased to 111 meter, whereupon a precast RC scaffolding was constructed for the first time in the world, using the cantilever method, according to Boško Petrović lecture held during the period 1991 to 2004 in Novi Sad. The critical moment during the construction of the bridge was the phase of introducing pressure force in the semi-arch and specifically the moment lifting a structure from scaffolding. The analysis of the influence of arch during the construction phase was conducted in the tower rad impacts in the assumed that the old calculation was done in 2 ways, via the chain polygon and force, and tabularly by dividing the half of the arch into 10 or 2 parts. Because the symmetry, it was enough to analyze half of the arch. This is cross-section view bridge. This is cross-section, and it's arch hollow, but it is longitudinal section and plane of the bridge. This magnificent RC and PC bridge is in Novi Sad, was built according to idea in engineer Branko Žeželj, academic professor, inventor, innovator, reasonable designer were Ilija, a responsible designer were Ilija Stojadinović, Mostogradnja, and Dimitrije Ćertić, then IMS Institute. The designer of the producer, the propping of bridge was Boško Petrović. The contractor was the Belgrade company, Mostogradnja, which was founded in Titel, and at one time had a business unit in Novi Sad. About the shape of the arch in picture, in order to follow them in this paper easily. The necessary say something about shape of the arch and the cross-section. Arch of smaller span are usually of solid cross-section, while with large spans is light hollow arch dominates. It is the same of this case. The arch consists of 2 rectangular upper, it is upper and lower part, which are vertically jointed by a wall and the wood. So the middle part is hollow. It's a solid model extrude for analysis shape of beam element is not solid element. It's for this moment, and we on next slide we can beam section at its upper and lower part of arch. It's a big arch, and its analysis for order iteration for different rib of height for monolith table after construction during building. This is normal forces at a vertex of large arch. This is, and normal forces per part arch is 8,744 kilonewton. It's small arch solid model. It's a hollow construction. And displacement in the x direction, horizontal, the upper part of arch moves towards and the central top, while the lower part moves towards and supports. Maximum arch displacement is 6 millimeters. There is difference of moment of upper part in relation to lower part of the arch is half a millimeter. This displacement was correct in the actual project throughout history with hydraulic presses. It is displacement of arch in the vertical direction, in the largest in the crown, this, and decreases toward the support. The displacement in the vertex about 6 millimeter is 6 centimeter. Between the upper and lower arch, there is difference of 0.1 millimeter at the top, and it also decreases toward the support. About scaffolding arch, considering the two different span of the large and small arch, and 208 millimeter RC prefab scaffold was made to large arch in order to achieve the requirement of free fairway profile during construction. Fairway profile during construction. Prefabricate RC scaffolding consisting the arch and prop. For the support of RC scaffolding, temporary PC piles were first driven in the bottom of the Danube, and then they were connected with raft about water, like small Iceland. The layout of scaffolding for the arch can be seen in the picture below, which was taken by Mijat Trojanović. So it's for Mijat Trojanović. It is fixed scaffolds for small arch, this, and prefabricated scaffold for long arch. This is monotable precast RC arch scaffolding and prop for scaffolding. This is the name Iceland. It is raft for pile, pre-stressed concrete driven in Danube, left and right, and this is a prop. It is prefabricated scaffolding long arch. A similar structural system was applied to mainland Kirk Bridge, where the arch is 3 cells and only inner cells is prefabricated, while the neighboring cells are cast on site. Instead of piles at the junction of large arch of the prop, a caisson was constructed here, founded of the rock, but is the pile. The prop is a support on caisson. According to the lecture Boško Petrović, BP, held during the period 1991 and 2004 Novi Sad, the first critical moment during the construction of the bridge was phase of introduction pressure forcing into semi-arch and specifically the moment of lifting the structure from the framework scaffolding. Žeželj had an inconvenient custom of sending the one who designed something new to carry it out. Since BP designed the propping of the arch that ungrateful honor in this case fell to me. While the workers were preparing the press in the crown for the propping the first arch stage, I accepted that. Tell me when the force reached 99% in the value of, then slow down the pumping, which they did. Specifically, the pressure was measured with manometer, but they had pressure force indicate in the table as well. I was told what the force was, but nothing was happening. I should have shown some moment and last squeak, but nothing was happening, and the force was already 100, 102, 103%. I stopped pumping force before 105% because the semi-arch suddenly jump and detach from the formwork scaffolding and bridge could break. And then I'm afraid to think what will happen and project and to me. It was already night. I told the weight lifters and lifters and release the tension presses, check the hoses again and start again tomorrow. The next day I came to the construction site and they told me, you were right. One part of hose got tangled inside the scaffolding, so it was almost invisible in the dark. That's why I didn't transmit the pressure to the press. How when I was approaching 100% and little, and the force, there was a screeching sound and concrete and the artwork, and they over time as the command future arch. Currently, only to 1/2 rose from the framework. This is the distribution hydraulic pressure, and upper side of arch is smoothly. This is a 8 pressure on upper part of arch, and down lower part, and the upper part is 6 pressure. This is a cross section and the longitudinal sections. This is longitudinal, a cross section, large and little one arch of bridge kirk. This is a central cell. It is precast, but left and right is concreting in cast in place. This is a large span, is 3,009 meters. Foundational large arch due to RC propping and caisson. Ida Studinci and Stanko Šam later applied the principle of prefabricated scaffolding and cantilever construction of RC arch on the bridge itself, first on Šibenik Bridge, Šibenik Bay in 1966, and Pag Bridge, mainland Iceland of Pag, 1969, yes, until the multi-decade world record on Kirk Bridge, mainland the island of Saint Marco and Kirk. So Žeželj, by using prefabricated RC scaffolding, brought arch, RC and PC bridge of large span back into play on the world stage. This is a schema cantilever building of Arch Kirk Bridge. This is a prop of long bridge and near the caisson. Designer team for Kirk Bridge is Ilija Stonadinović, Vukan Njagulj and Bojan Možina. Builders is Stanko Šam, Ilija Stonadinović, Dragan Vukadinović, Veselin Radević, Nikola Krgušić, Arsen Pribić koji kasnije radio u Novom Sadu, mostogradnji, Ilija Vučković, contracted iz Mostogradnja, Belgrad, contract specified for prefabricated deck construction iz Hidroelektra Zagreb. Conclusion: the specificity of construction of the scaffolding and arch of the Žeželj bridge in Novi Sad enabled after 20 years of development achievement the world record Krk Bridge, mainland Island of Saint Marko Krk. Design was Ilija Stojanović and builder was Stanko Šam. It is acknowledgement for Ministry of Republic of Serbia, contract on 2024. This is a reference.